not the worksheet, the exercises that went with the molarity activity, the last page. Let's go through how to do this. So when you see that you have to prepare this from solid copper 2 sulfate, that means I have to figure out a mass, right? Because I have scales that I can measure masses, but I don't have scales that can measure moles, right? So I have to use the numbers I'm given to figure this out before I can actually make this. Well, I'm going to take my 0.1 molar, 0.100 molar copper 2 sulfate solution, and for the method I'm going to use here, the dimensional analysis method, like the one I just showed in the key for the quiz, I'm going to take that capital M and turn it into what it really is. So I can do unit cancellation, okay? Once again, if you want to plug in the equation and do algebra, you can do that as well. Moles of copper sulfate per liter of copper 2 sulfate solution, right? So far so good? I'm not going to write out that every time because it's going to be a lot of extra writing, but just realize I'm dealing with that copper 2 sulfate solution. What are the information do I have in this problem that I probably want to use to figure this out?
500 ml.
I have that volume, right? So basically we have a known concentration of this copper 2 sulfate solution. We have a known volume of this, right? We have to somehow figure out what mass of copper 2 sulfate solution we need, or copper 2 sulfate solid we need to use to make up this solution of this concentration, this volume, right? So that 500 milliliters, what should I do with it based upon what we just saw in the quiz? I might get that way, a little bit of a hint. What should I do with that 500 milliliters? Should I leave it in that unit?
Convert to liters.
No, my units are moles per liter, right? So whenever I have unit cancellation, I need to convert my milliliters to liters. So I'm going to do 1,000 milliliters per liter, so I get 0.500 liters. I'm going to erase my copper 2 sulfate. It kind of gets, you kind of already know that's what it is. More busyness on the whiteboard. Okay, so now I'm going to use those two numbers. What can I figure out using those two numbers? Can I figure out grams directly from using these two numbers?
Moles.
Do you see grams? Here, here, or here?
No.
You see moles, liters, and liters. So using molarity as a conversion factor and knowing the volume, I can figure out the number of moles of copper 2 sulfate in 500 milliliters of a 0.100 molar solution, right? But I can't figure out grams yet, but I can figure out moles. I'm going to go question mark moles. Nice, copper 2 sulfate. I'll just write out the whole word liters here, or liter. And you'll notice that liters cancel out. If I do this math, 0.100 times 0.5000, because I force the from that number, I'm going to get the moles of copper 2 sulfate. Why don't you plug it in with me? Well, that math I could have done in my head, I guess, but I just plug it in my calculator. 0.0500. I'm going to round to 3 sig figs right now, although actually, to round to the end, really, but another 0. Okay, so I have my moles of copper 2 sulfate, right?
Right.
What I want to get, I want to figure out the mass of the solid copper 2 sulfate. Can anyone give me some advice on what I should do?
You use the molar
Molar
mass
mass.
ratio of copper 2 sulfate.
Exactly. Determine the molar mass of copper 2 sulfate, which of course I need the table to do that unless I've memorized all those molar masses. And using molar mass, which is grams per mole, convert moles to grams, right? Now before I go on to that, I want to remind you again, this problem here, I did this right here, this line here, the dimensional analysis way, where I converted my capital M to moles per liter, right? My volume to liters, and I just canceled my units. I could have also plugged in, well, let's knock that down. I'll pick up the rest later. I could have also plugged in my molarity right here, my volume of liters right here, right? And then done the algebra. So like I said a couple times already, if you prefer that method, you can use that one. So let's figure out copper 2 sulfate molar mass. So 63.55 for copper, right? What's the molar mass of sulfur? 32.07. We have 4 oxygens, right? So 4 times 16 is 64, right? Okay. So 159.62 grams per mole is my molar mass. Is that the correct answer, by the way, everybody? Did I make a calculation error or anything?
No, that's right.
Just making sure, because you know it can happen, right? 9.62 grams per 1 mole. And when I use molar mass as a conversion factor, you'll notice what I do is I make a horizontal line instead of, so here I did kind of a line at kind of an angle here, grams per mole, but when I use it as a conversion factor, I put a horizontal line so I can clearly cancel my units in my setup, right? That I know I should be multiplying by that number, not dividing. So take that 0.05, my moles of copper 2 sulfate times that molar mass, and here's what I get. Get that same answer for those who plugged it in? Okay, so what does that mean? What does that calculator number mean?
That's the clear.
Math, we need to weigh out, so I'm gonna write this down. So 7.98, right? Grams of copper 2 sulfate. So, now we have to actually make that solution. And I just happen to have a graduated cylinder that can fit up to 1,000 milliliters. So what's my volume I want to make? 500. So this is big enough, isn't it? And I just happen to have, luckily, a container that contains almost 7.98 grams. And the reason I know it's not exactly is because I spilled some of it this morning. I was taking it out from under the cabinet. Okay, because I had it ready for Tuesday and we didn't get to this. So we're going to pretend it has 7.98 grams, okay? What I also have here is I have a combination hot plate stir plate, like we used in the, one stir here this side, okay? Like we used in the lab a few weeks ago. What can happen if you turn on the stir thing? Of course, might as well make that stir, can stir, right? So what I'm going to do is I'm going to get some water. So I need to make an aqueous solution of this copper 2 sulfate right now. Normally we don't turn the stir thing on ahead of time, but I just did because I decided to. So we're going to pour in some water into our graduated cylinder. The reason I'm pouring a little bit of water first is sometimes my compound sticks to the bottom, kind of like when you make Kool-Aid, you know, it sticks to the bottom. Then I'm going to pour in my 7.98 grams of copper 2 sulfate. I'm going to keep on pouring in water up to the 500 milliliter mark. So what I'm not doing here is I'm not adding 500 mils of water. I'm measuring how much water to add after I put in my copper 2 sulfate. And so I'm not doing perfect job here, but I'm going to say good enough. So I'm going to be adding a little less than 500 milliliters of water because that copper 2 sulfate takes up some space, doesn't it?
Yes.
Not a whole lot. I mean, it takes up a mil or two of space. So when I talk about doing this, then I don't say add 500 mils of water. I say add water up to the 500 milliliter mark. Okay? So that's how you make that solution. Now I think because of distraction, I'm going to just take this off. Which way is turned off? That's the wrong way. Is this the off way? Okay, that's off. I'm going to move this down here for a little bit. And then I'm going to ask another question. From this. So I've made up my 0.1 molar copper 2 sulfate solution, right? Take these off now, I guess. What I want to do now, someone asked you to dilute your 0.100 molar copper 2 sulfate solution. 2.0620 molar molarity copper 2 sulfate. So I made it my 0.1 molar copper 2 sulfate solution, but now someone says, no, I don't want 0.1, I've changed my mind, I want a 0.0620 molar copper 2 sulfate solution. I have to dilute it. So on Tuesday, right at the end of class, we got started talking about dilution, but hadn't gotten so far into it. I want to just show you an equation here we're going to use to do dilution problems. Once it's put on the screen. Okay. So when we do a dilution problem, we're going to use this equation, which, by the way, you should also memorize this equation. So the cool way to write this, MIVI equals MFBF. I stands for initial, F stands for final, for concentration volume. Another way people sometimes talk about this equation is this. M1 B1 equals M2 B2. So this is my initial, this is my final, okay? So let's talk about using the dilution equation to figure out the answer to this next problem. So most of us would know, even before we do the calculations here, that when you have a more concentrated solution and a less concentrated one, what would you probably want to do? Add some water to it, right? To make it less concentrated. The question is, how much water? That's what we did the calculations for, right?
Right.
Okay, so my M1 is my initial molarity, my more concentrated solution, right? Which one of these two numbers is more concentrated? The top one. I'm going to put 0.100 molar as my M1. My more concentrated solution is my M1. What's my B1?
500 milliliters.
That's my B1 from over here, because I made it 500 mils, right? On a real another problem, I would tell you 500 mils of that solution. We'll do 500 mils here, okay? This is my B1. Now in this case, if I wanted to convert this to liters, I could. But when you're using the dilution equation, you don't necessarily have to change it to liters. With molarity, you have to, but with M1, B1, M2, B2, you do not, because it's like a ratio, basically. And I'll explain that in just more in a little bit once we do this calculation. What's my M2? Oh, sorry, what? Someone said something, I thought. Oh, over there?
Both have to be over the center.
Yes, they both have to be the same. Whatever you choose for the B1, it has to be the same units for B2. If you decide to switch to liters here, then your answer here is going to be liters as well. So you have to keep those units consistent, but you don't have to switch to liters if you don't want to. What's my M2, excuse me?
0.100.
0.0620 molar, right? And what's my B2? That's what I don't know. I'm going to put X or question mark. I just put question mark when I do my, I don't know what that answer is, right? So it's just an equation, one variable, three variables known. You're going to plug it in, right? So let's plug that into our M1, B1, M2, B2 equation. I'm not going to put my units here now, because I already have the units here, but I know if I have milliliters here, what are my units going to be here? Milliliters also. Okay. So I'm going to put M2, of course, then I'm going to divide both sides by this. So my answer is going to be okay, here's what I get in my calculator.
Yep.
Yes, okay. So I get 806.45, and so we have three sig figs and are least precise. I'm going to put 806, and I'm going to make sure I use the same units for my volume milliliters. Okay, so this is a case where you don't have to switch to liters when you're using the dilution equation, but make sure your volume units are exactly the same, okay? Or make sure if you figure out, if you already have the one given as milliliters, you leave it that way, your answer is going to be the same unit for the volume, okay? What does this mean I should do? Let's just get this out again.
Should add 306 milliliters of water.
Exactly. So I already have 500 mils total volume here, don't I? Which includes the volume of the compound that's dissolved in there. So I happen to have do I have 300 mils? Not quite. So I'm going to go add a little bit more. Some water here. So I'm going to take my 500 mils of solution. Goggles back on. And I'm going to add water up to the 806 milliliter mark, which is basically